Even better. So I will get started then, if it's all right. So hello, everyone. So very happy to be there virtually, but I am sorry I'm there virtually. So it's sort of the situation where I was very much looking forward to coming and presenting in person, and then you end up with kind of a cold. It's like, well, I reflected on the audience and thought a full room full of software professionals is too expensive to risk getting you all sick. So here I am via Teams. So sorry for that. So this project, I'm going to talk maybe for less than 20 minutes, we'll see, to give you a summary of what we've been up to in Sprint 23 and what we plan for in Sprint 24. So the project is called Engineering Knowledge Flows and Large-Scale Agile Systems Development, and we're project number 27. So this project is run by Eric Knauss, my colleague, and I'm Jennifer Horkoff. And we also have some associated researchers. So we have Hans-Martin Heyn, who's currently a postdoc, but about to become a permanent faculty member as a teacher, and we're really excited to have him participate. We also have Jörg, who is a postdoc that will be finishing with GU in March, but is still participating. And then we have associated also Rebekka, who you might have seen speak this morning. So she's come back to us now as an associate professor, and we're really happy to have her back. So we also, of course, have industrial partners in this project. So we have a number of very active partners, so Ericsson, Grundfos, Volvo, and also Zenseact to a certain extent. And then we have a large list of partners who have been active with us in the past and are a little bit more silent these days. And this is usually, I think, just due to not necessarily having the people with enough time available to kind of dedicate to research, but I think they're still interested. And of course, we're happy to have them pop back in at any point. So I should say, of course, if any of these things that I described today interest you, we're very interested in more partners, especially more active partners. So you're very welcome to get in contact with Eric or myself. So what I'm going to do today is just talk a little bit about what we were up to in Sprint 23, what are our goals, what did we actually do, what did we discuss, and then what are we planning to do following up on that for Sprint 24, including goals, activities, and some of the planned theses that are coming up. So the overall mission is to accelerate large-scale agile system development by improving knowledge flows. So we changed, I think, our project topic a few years ago. So we were focusing on large-scale agile requirements engineering, but I think the term requirements engineering was sometimes a little bit problematic. People have a fairly narrow view of what that is. And what we were doing is, of course, much broader and more about broader knowledge engineering and knowledge management. Of course, myself as a requirements engineer, I think requirements includes all of this, but in order to be more descriptive, I think this is probably a bit of a better name for us. So overall, we're focusing on kind of two main goals in the next few sprints. So we want to focus on the design and evolution of information models. And this is a topic that has come to us essentially from our industrial partners. So they themselves are interested in having sort of universal kind of grounding information models. So things like traceability information models, requirements information models, and covering all other elements or other elements getting into design and architecture. And this helps them to kind of coordinate work and to have sort of a tool independent way of working and coordinating and things like that. And so we're interested in how you maintain and manage these sorts of models in these large organizations in large-scale agile systems. We're also very interested generally in knowledge and information management strategies. So how do you manage and share and work with knowledge about things like, requirements, but also testing, design, architecture. We want to look into concepts, methods, and examples of how you would have a strategy for this as part of, again, large-scale agile systems. So these are sort of some of our overarching goals in the last few sprints. So what we did in Sprint 23 is we used these goals, but focused a little bit more. So we continue to investigate how potential combinations of Bomi, which I'll explain in the next slide, and collaborative traceability principles could be used to facilitate these large-scale flows in this context. And then we looked a little bit more at principles coming from system engineering and knowledge management, and looking how these sorts of principles guide you towards managing knowledge and strategies and best practices and things like that. And so we had associated workshops for each of these, and I'll describe them in a bit more detail coming up. So first of all, Bomi, just a little bit of background because we keep mentioning it, and otherwise you won't have any idea what we're talking about. So in the past sprints, we have a kind of a conceptual methodology and also modeling language for something called Bomi, which is boundary objects and methodological islands. So this is based upon the PhD work of Rebekka Wohlrab, who you might have seen speak earlier today, and also former PhD student Rashida. And so it's a modeling language and a method, but what we're trying to do is to understand in large scale agile, how do you actually manage knowledge? What are your sort of boundary objects or interfaces between different teams? So you have different teams, or what we're calling methodological islands, who work in different ways. One might be more agile than the other, and one might be remote, one might be, systems, one might be more on hardware. Different teams doing their own thing, but of course they have to coordinate and we have to manage knowledge. And we do these through these boundary objects. And these could be things like backlogs, user stories, requirements, test sets, architecture, documents, plans. So all the sorts of, documentation that we use to coordinate between each other. So we have this sort of method to look at, how these things are used, by whom, what roles, what islands, how are they governed, etc. So that's the mental model, and in practice, in a kind of an anonymous company example, they look something like this. It's a bit of a simple one, but you have a boundary object who's used by two different methodological islands, product management and the development team, and then different roles like the product owner and developer use this thing, and it's governed by certain roles, etc. So this is Bomi, and this is something that we've come up with several sprints ago and have been in the process of evaluating and using and developing. So what we did this sprint, we had a kickoff workshop to plan, of course, and then Eric was involved in a student project with Ericsson on managing knowledge with TRex. So this is another output from our project, which I don't get into in too much detail, but TRex is essentially textual requirements management. So if you can imagine the way we manage code and things like, Git and GitHub, but doing so with requirements in text, using smart versioning, smart traceability, and updating in kind of a nice way that's more in line with how developers work. So there's a tool called TRex, which has a version at Ericsson and also an open source version. And this is a continual point of development in our project. So there's a student project working with Ericsson and TRex, and then there'll also be a master thesis kind of expanding TRex to focus more broadly on knowledge management coming up in this sprint. So we had one cross-company workshop that was looking more at these principles of system engineering, and I'll talk more about that in a couple slides. We had continuing work on Bomi. So our postdoc Jörg was continuing to develop a tool, or developing a tool to kind of support Bomi modeling and views and sanity checks, smells, and things like that. And that's going to be put together in a journal paper we're going to submit soon. In October, we had a second cross-company workshop looking specifically more at information models, and I'll talk about that in a few slides as well. And then the typical thing, of course, we had an end of sprint cross-company workshop, compiling and reporting. So the first workshop we had this sprint, we were looking at principles of system engineering and knowledge management. So this was an idea brought to us by some of our company partners. So they tend to be a little bit more in the system engineering and system science world. And there's a lot of really interesting theories. So the question is, how do these theories kind of gel with or support or conflict with some of our practices and our research output from this particular project? So how does it relate to requirements engineering, Bomi, traceability work, TRex, etc.? So I gave a short presentation kind of summarizing the very nice presentation of Gary Smith in the system science world. And then we had some very nice presentations from Jesper and Robert coming from industry, and then open discussion and action points. And this was very nice because it was a totally in-person workshop, which was really lovely. We hadn't had one of those for a while. So I gave a summary of Gary Smith's talk. And so this is the wonderful slide that is completely not mine. I borrowed it from Gary Smith's talk. You can see the reference at the bottom. So this was a really interesting system science talk where he takes about like 6, 7 different system science theoretical frameworks and just put them on top of each other to show how they all relate to everything. So here you can see the Knauss framework, and also a number of other different frameworks. And this is interesting to kind of classify our systems in this way. And based on these classifications, we understand what sort of practices we need. Like, do we need, to use established good practices because we're sort of moving towards the more obvious side, or are we in complete chaos, in which case we need to be very agile and focus on coming up with novel practices, for example. So that's a very, very brief summary. If you're interested, I recommend Googling this talk. It's very nice. So I looked at how, this talk and then how this relates to theories and practices from requirements engineering. And there's some relation, but in general, in requirements engineering, we tend to focus a little bit more on methods and tools and less so on theories and best practices. So that's maybe a bit of a weakness in our area and something we need to get over. And then we had a very nice presentation from Jesper from Grundfos, who was telling us more about this Knauss framework and how, classifying a system in terms of chaotic, complex, complicated and ordered, helps tell you what sort of methodology and how you approach the system, like what level of agility, whether you use best practices, whether you develop practices, etc. So I won't, I don't think I could do justice by summarizing this so very well, but it was a very fascinating talk, very interesting. And we also had a talk by Robert, who was telling us about their work in order to deal with system of systems and use more taxonomy and ontology to define a common language within their company. And how this was, of course, something they're working towards, but there's some challenges there. So there's some challenges in modeling, and boundaries, mixing structure and abstraction, uncertainty about modeling, you know, trying not to reinvent the wheel, etc. So overall, I thought that was very interesting that at least in this particular company, they're moving towards kind of, again, having a global information model and getting into things like taxonomies and ontologies. So this is stuff that I learned and studied for many years in university, but which I hadn't necessarily seen applied too much in practice. So it's nice for me to see some of this more theoretical work actually being applied in a large-scale, realistic way. I think that's very interesting. So that was our first workshop. And then our second workshop, we focused more on this topic of evolution or information models, which is, you know, very related, especially to this last talk by Robert. So here we were hybrid and we had a shared Miro whiteboard. And we looked at key questions like, why do you want to have an information model for your company? How does this relate to some of these Cynefin different system characteristics, etc.? What are the key steps and challenges in information model design? So how frequently do you need to update them? How frequently are they changed? Of course, this is all being done in an agile context. So to a certain extent, our information model should also be agile, but they can't be too agile because they're meant to be, you know, for coordination. They are, in a way, a type of boundary object. And so there's a bit of a balance there. And so what are the key challenges in information model evolution? How does this relate to some of our previous topics and theories, so RE activities, etc.? And how do we relate Bomi to information models? It's kind of for a different purpose, but I think that these two types of modeling approaches are complementary. So these are the sorts of things we discussed and want to investigate a little bit more in coming sprints. So the key findings from this particular workshop is, you know, there's challenges in versioning of these information models and hard versus soft versioning. Different people want to view different parts of this information model. So it should be different depending on the role of who's looking at it, a developer versus a product owner. So you need viewpoints for specific roles, but then of course you need correspondence rules. These views must be consistent. And there's a real trade-off between sort of, you know, enough detail for concrete guidance versus having too much detail, then making it very hard to make it up to date and robust. And, you know, return of investment in information models. So there is certainly a use here, but how much investment do we want to pay versus, you know, how much benefit we get from it? So in general, this is a challenge. And, you know, one of the key challenges is designing these sorts of models for change, enabling scripting and systematic changes. And one of the major points here is to avoid vendor and tool lock-in. So you want to have kind of an underlying taxonomy or ontology for all or part of your business such that you can give requirements to the tooling as opposed to being shaped by the requirements of the tooling. So that's one of the main motivations here. In terms of Sprint 24, we're going to kind of continue on in these various investigations. So we're going to look at principles of design and solution of information models. So more about how does this actually happen in practice? What are the specific challenges and practices? How does it relate to, you know, kind of sub-information models like requirements information model, system information model, traceability information model? And how does this act as a boundary object in various roles? And then more towards guidelines for knowledge and information management strategies. So the first one is all about information models, and the second one is more about general best practices and guidelines for sharing and managing information in complex agile systems. So how can we be inspired by system engineering principles and frameworks like Cynefin? And, you know, how do you relate this to organizational and architectural breakdowns and into common agile ways of working? So this all has to work together in a complex way. So planned activities, of course, we'll have a number of workshops again, and we're going to focus on some thesis projects. So I am going to supervise a bachelor thesis looking at applying Bomi to some of the common standards used in these organizations. So what is the, for example, some of the ISO software standards tell us about coordination and boundary objects, and can we capture this with Bomi? And then I think Eric is supervising a thesis on tools like TRex to empower development teams to manage knowledge. So how can you use this textual requirements tool for broader knowledge management and things like that? And we'll have, again, we think 2 cross-company workshops, one to dedicate to design principles of information models like we described, another one more for general principles and practices for managing information and knowledge. It's thesis season, so we'll have lots of different theses and more work on Bomi and especially how to relate it to information models. And I think we will also have some probably per company workshops doing some Bomi modeling because we have some new participants since we last did this. So I think we can kind of expand and understand a little bit better how this can work in different contexts. I think this is my last slide. So just to summarize our planned thesis. So we have the TRex one that I mentioned, broadening it to knowledge management, Bomi and standards, like I mentioned. And then we have a number of other master's theses which are relevant to the project, but not explicitly with software center companies. So we have one on exploration mode requirements engineering with a kind of a different part of Volvo, one on using machine learning models to evaluate requirements quality, and another one on kind of a requirements view of ML ops. So I think these will all be kind of interesting and relevant for the project. And like I said, we're interested to hear from you. So we have a long list of companies, but we have a shorter list of very active companies, although we're very happy to have them and grateful for their contributions. So if any of this sounds interesting and you want to get involved, please email Eric or myself, and we're very happy to hear from you. And I'm also happy to take questions.
Thank you so much, Jennifer. I am well set up with 2 microphones, so please, Jon, use one.
Hi, John from Volvo Cars here. I'm not working in this domain, but usually I get this feeling that people working with this information modeling, they like their models. They get sort of a feeling of, wow, we can fix everything with this. But when you apply it to the complex product out there in the field, it gets terribly complex. It gets terribly difficult to maintain, and and by the way, the people out there, they didn't understand the meta model. So have you? I saw you have simple examples, but have you really have you looked at also how do you scale things like this, and what are the consequences? Not only the good things.
Yeah, that's a really good point. So what I showed were examples of Bomi models, not really information models. They're related, but not quite the same thing. So those things, yeah, they're difficult to scale. Information models are a little bit easier to scale, but all of these things that you just mentioned are very valid challenges. I should say it's not our idea to work on information models. It's the companies that are working on it. And so we're just happily going along as researchers. I have a background in modeling anyway, so I'm really excited to see that the companies are interested in these sort of more large scale formal models. But you're right that they are challenging to use. And I mean, the situations you described, probably that means the models have too much detail, because if it's just too much work and too difficult to update, then it covers too much. But yeah, these are all really valid points. And these are some of the sorts of things that we will try and investigate. So how much modeling is enough? How do you make it usable for certain views? Because you're right, you might not understand the meta model, and it's important that you understand the part of the meta model that actually relates to you. So I think this is very interesting, but I also think that there's years of research in the modeling community and in like the Models Conference and Conceptual Modeling Conference that will really help here. So I think I'm excited to try and make this more applicable, but you have a very valid point.
We have a question also from Robert from Bosch.
Hello.
Oh, and I am not moving. I need to run.
Thank you. Hey, Jennifer.
Hi.
So thanks for the presentation. I was thinking about one area. You remember when we discussed the previous project around APIs, the interfaces. We talked a lot about the life cycle. And one thing we see internally when we're working both with the Wikipedia approach with all our information and the knowledge, and we are moving to, we call it XS code, moving everything into the code versioning system. But in both of these, we have a challenge when information and knowledge becomes deprecated or not valid anymore. So we don't have a really good mechanism to remove old Wikipedia pages or wiki pages and these kind of things. Will you also look at life cycle of knowledge and information and how to handle that?
Yeah, that's a really excellent question. So like you said, that's something we looked at in the API project. And I really thought that was a really nice area of interest. I thought we'd come up with some really nice models. So in this Bomi framework, where you're looking at boundary objects, and an API is a specific type of boundary object. So it's a more technical kind of code-based boundary object, as opposed to something like user stories or test cases. And so the lifecycle work that we did on APIs could apply potentially to other boundary objects, but not necessarily. So is the lifecycle of an API the same as like the lifecycle of a backlog, or the lifecycle of a test suite, or lifecycle of a design document? I don't know. I think that would be actually really fascinating to look into. So I'll definitely take that back with us. I think it's a really interesting idea, and we already have a lot of work there for APIs. So it hasn't come up, but I like that idea. I think it's a great idea.
Then I think we end that presentation. Thank you so much, Jennifer.
Yeah, thank you, everyone.
I hope you recover well. Great.
Yeah, thank you. Me too.
Thank you very much.